This is part 2 of Lecture 9 on acid-base balance. This information can be found in Chapter 26 of your textbook on pages 1013 to 1037. Water intake must equal water output, and this is equivalent to approximately 2,500 milliliters per day. Most water is taken in by ingested foods and beverages, but also a small amount comes from byproduct of metabolism. Metabolic water, the water of oxidation, is a water produced by cellular metabolism. In terms of water output, 60% is accounted for by urine. You also have insensible water loss through skin and lungs, perspiration, and feces. The osmolality is maintained around 280 to 300 millimoles, and a rise in osmolality stimulates thirst and causes a release of the antidiuretic hormone. A decrease in osmolality causes inhibition of thirst and causes an inhibition in the release of antidiuretic hormone. The thirst mechanism is a driving force of water intake, and it is governed by the hypothalamic thirst center. Hypothalamic osmoreceptors detect extracellular fluid osmolality and are activated by either an increased plasma osmolality of 1 to 2%, dry mouth, decreased blood volume or pressure, angiotensin II, or baroreceptor input. Baroreceptors detect the pressure in your blood volume. The drinking of water inhibits the thirst mechanism. Inhibitory feedback signals include the relief of dry mouth, activation of stomach and intestinal stretch receptors. Obligatory water losses explain why we cannot live without water very long, and these include insensible water loss from the lungs, skin, and feces, sensible water loss from urine to excrete waste, and has a minimum daily loss of 500 milliliters. The volume of urine excreted and solute concentration also depend on fluid intake, diet, and water loss via other avenues. Water reabsorption in collecting ducts is proportional to the release of antidiuretic hormone. A decreased antidiuretic hormone leads to dilute urine and a drop in the volume of body fluids. An increased antidiuretic hormone leads to concentrated urine due to reabsorption of water, causing increased volume of body fluids. The hypothalamic osmoreceptors sense extracellular fluid solute concentration and regulate antidiuretic hormone accordingly. There are three principal abnormalities of water balance. First is dehydration. Extracellular water loss is due to a hemorrhage, severe burns, prolonged vomiting or diarrhea, profuse sweating, water deprivation, diuretic abuse, endocrine disturbances. Signs and symptoms include a cottony oral mucosa or cotton mouth, thirst, dry flushed skin, oliguria, and may lead to weight loss, fever, mental confusion, hypovolemic shock, and loss of electrolytes. Hypotonic hydration is cellular overhydration or water intoxication. This occurs with renal insufficiency, that is kidney disease, or rapid excess water ingestion. Extracellular osmolality decreases, causing hyponatremia, and results in a net osmosis of water into tissue cells and swelling of cells. Symptoms include severe metabolic disturbances, nausea, vomiting, muscular cramping, cerebral edema, and possible death, and is treated with a hypertonic saline. Edema is atypical accumulation of interstitial fluid, resulting in tissue swelling, but not cell swelling. Only volume of interstitial fluid is increased, not of other compartments, and it can impair tissue function by an increased distance for diffusion of oxygen and nutrients from the blood into the cells. It could be caused by increased fluid flow out of blood or a decreased return of fluid to blood. And this is the end of part 2 of Lecture 9 on acid-base balance.